Andrea and Carter are going on a picnic. To prepare for the picnic, Andrea buys 4 bags of granola and 3 bags of dried fruit and spends $51.50. Carter buys 2 bags of granola and 4 bags of dried fruit and spends $45.50. Write and solve a system of equations to determine the cost of a bag of granola and the cost of a bag of dried fruit. What's nice about word problems are the answers need to make sense in terms of the problem. What is the problem asking us to find? The cost of the bags of granola and the cost of the bags of the dried fruit. Well, in the real world, when we're working with money and currency, money works in positive numbers for costs of items. And those costs can be whole numbers, the dollar bills we give out, or it could also have change, the pennies, nickels, dimes, quarters. So now let's set up our system of equations. Each equation is going to deal with a different person. So our first one is going to be Andrea. With Andrea here, the information listed above in our problem states that Andrea is buying 4 bags of granola, 3 bags of dried fruit, and spent $51.50. While I could use X and Y, I'm going to use more practical variables to represent what the problem means. So instead of 4X, I'm going to do 4G for the granola plus 3F for the fruit equals the total $51.50. The second person in the problem was Carter. And the information that we know about Carter is the following. Carter buys 2 bags of granola, 4 bags of dried fruit, and spent $45.50. So Carter's equation is going to be 2G plus 4F equals $45.50. What we can notice here is everything is lined up and they're all in standard form. I have my G's here, my F's here, the equal signs, and the numbers. While we could solve each one for one of the variables, such as y, and graph them, graphing is not the most efficient, nor is solving one of them for a variable and substituting it in. So for today, I'm going to solve this using elimination. When I eliminate a variable, I have 2 options here. I could eliminate G, solve for F, or I can eliminate F and solve for G. It's a good practice to find a strategy and work with the one that's easier to eliminate. If we examine our G's, is it easier to eliminate G by turning 2 into a 4, or eliminating F by turning a 3 into a 4? Best strategy here is to turn the 2G into the 4G. I'm going to multiply this entire equation by 2. When I multiply everything here by 2, I get 4G plus 8F equals 91. The top equation I have not changed, so that is going to stay the same thing. 4G plus 3F equals 51.50. Here, since the variables are the same, I'm going to subtract the 2 lines. I'm going to show you another method later on where instead of subtracting, I'll be adding them. When I subtract the 2 lines, I am going to get my G's to cancel out. 4G minus 4G is 0 G's. Then I have 3F minus 8F is negative 5F. We lost our page here, 1 sec. There we are. So from here again, we are going to have negative 5F equals 5150 minus 91, negative 3950. Then to solve this for f, we're going to divide everything by the number with the variable here, negative 5. And we find our solution for f to be 7.9. This was the fruit, the dried fruit. So we scroll down below. The cost of the dried fruit is 7.9. This is money, so I'm going to make it 2 decimal places, 7.90. Then from here, we need to solve for g yet to find the cost of the bag of granola. We can pick either one of our original equations, the black Andrea equation or the orange Carter equation. I'm going to substitute using Carter's because the numbers are smaller. 2g plus 4f equals 45.50. I will then substitute what I just found for f in. So 2g is still 2g, but 4f becomes 4 times 7.9. That is going to be equal to the 45.50. Solving for g here, we get 2g. 4 times 7.9 is 31.6 equals 45.50. Move the number without the variable first. Subtract 31.6 to both sides. We get the following. 2g equals 13.9. And then the final step, separate a number from a variable, divide it. And we get g equals 6.95, which is the cost of the bag of the granola, which is why I used g for the variable. Now I hinted earlier on that you may not subtract the two equations to eliminate. Let's say instead of subtracting, we wanted to add, and what we would have had here is instead of multiplying Carter's equation by 2, we would have multiplied this by negative 2. If we would have multiplied Carter's equation by negative 2, we would have had negative 4g minus 8f equaled negative 91. Andrea's would have remained the same. 4g minus 3f equals 51.50. Then when I would have added my two equations, we would have actually gotten the same exact thing we had up top there. We would have still had the negative 5f equaled the negative 39.50. So it depends if you want to solve it using the addition elimination or subtraction elimination. Just make sure when you do that one of the variables are eliminated, or you may have made a mistake. So that is how we solve part A. If I move to part B now, it says, please refer to the previous page for task explanation. It says, Andrea and Carter will both hike to the picnic area from the park entrance. Carter starts at the park entrance and begins hiking to the picnic area at a constant rate. Andrea starts at the park entrance sometime later, then Carter begins hiking toward the picnic area at a different constant rate. The picnic area is 3 miles from the park entrance. The graph below represents this situation. So again, I have Andrea and Carter yet. We have graphs here with lines on the coordinate plane, and they're clearly labeled which is Andrea, which is Carter. Since I used orange for Carter last time, this one here is Carter. The question asks, explain why the graph of Andrea's line starts at the ordered pair 20, 1. Well, 20, 1 is an ordered pair, and ordered pairs go x, y, and that 20, 0 right here. The reason for this is time is the x, so time is x, distance is y, and Andrea started 20 minutes after Carter. Which is why the x there is 20, and they didn't start for the first 20, which is why the distance was 0. Part C now. Explain what the solution to the system of equations graphed in Part B represents in the context of this problem. So what this represents is the time at which Andrea and Carter are both the same distance from the park entrance. And that is how we do Part C.